Mm. So, what is magnetic momentum number and what it is going to explain? Okay, what we are going to get from the magnetic quantum number. Generally, magnetic quantum number, which is proposed by Land. Okay, magnetic quantum number is proposed by what? Who proposed? Na Land. He proposed. Okay, and denoted by M. ML. Simply we can represent. Okay. This magnetic
What's that, sir? ME?
MLLLL. Okay. Magnetic quantum number depends on magnetic quantum depends on where it is going to depends on L value. Okay, that is uh, for any L value there are uh, 2L plus 1 ml values exist. 2L plus 1 ml values exist, and those values starts from minus L to minus L to 0 to plus L. Minus L to 0 to plus L, we can say that. Okay, na? This is what we can say about the mm, magnetic quantum number, right? Next one, what we can say?
Sir,
Tell me, Nana.
sir, minus L plus L, that means infinity only, no, sir.
No, I will tell you what is minus L to plus L. From where to where, I will tell you. While giving examples, you will get understand.
Okay,
Okay?
sir. But it's not infinity.
Not infinity. Okay? Mm. Okay. Mm. Okay, Nana. Your doubt clear, no? See, ML value, or it explains, or it gives information about the orientation of electrons. Okay, it gives you about the information about the orientation of electrons. That is number of suborbitals, number of suborbitals of a orbital. So what it will give? It will give information about the number of subsets of a orbital. We are going to get this. Okay, na? Hmm. Next point is uh, next one. For example, see, if
Sir,
L
once
equal,
can we go to previous slide? Sir,
Tell me.
sir, 1 minute. Sir, that means you wrote magnetic quantum number depends on L value, no, sir.
Hmm.
And L value depends on N value, no, sir.
Yes.
That means we can say that magnetic quantum number, all these quantum numbers depend on the principal quantum number.
Yes. Yes. We can. Okay, na?
Sir, what is the value of 12 plus 1 and minus L plus 1 plus L?
Here 2L plus 1 is the formula here, and the values are starts from minus L to plus L. Once I'm going to say example that you will understand, no?
Okay, sir.
See,
Thank
if
you,
L
sir.
equal to 1, how many values exist? Then, as per 2L plus 1 formula, how much value it will be the
3.
2 1 plus 1? That will
3
be how many
orbitals.
values will be there? 3
3.
values exist. And what are the values?
minus 1, 0, 1.
Those values are from where to 1? Minus L means minus 1 and 0 and plus 1. That means L equal to which orbital we can say? Which orbital L equal to 1 means?
Sir,
L equal to
p orbital, sir, p orbital.
L equal to 1 means p orbital, right? So that means what we can say in P there are 3 subcells suborbitals are there.
Sir, can you go to previous level?
1 second. Suborbitals are present. Okay, those values only vary. So this each ML value is there, no? Each ML value indicates so each suborbital. So that is minus 1 indicates px orbital, plus 1 indicates py orbital, and 0 indicates pz orbital. Okay, for 0 we can fix it as, whereas x and y we can interchange, no issue. Okay, but this is only fixed as per IUPAC standard. Hmm. Done.
No, sir, 1 minute. Sir, done, sir. Sir, here L means azimuthal quantum number value only, sir.
Huh.
Sir, here P means it's an orbital. In that suborbitals are Px, Py, Pz, sir.
Yes. Okay, na?
Sir,
1 minute is not over.
sir, there are 4P values, na, sir. 1P, 2P, 3P, 4P. In those again, Px, Py, Pz, sir.
Yes. If I'm
Okay.
taking 2p, no, that means it is going to have 2px, 2py, 2pz like that.
And of each one, the values are minus 1, plus 1, and 0, sir.
Yes.
For anything.
Yes.
Okay, sir.
Done.
No, sir.
Done, sir.
Arre Baba, make it fast now.
Done, sir.
Hmm. Second example, if I'm taking, if L equal to 2, how many values will exist?
5, sir.
5, sir.
5, sir.
So minus 2, minus 1, 0, plus 1, plus 2.
5 values are exist, right? What are the 5? Those are
Sir, minus 2, minus 1, 0, plus 1, plus 2.
Sir, that means the negative numbers and the positive numbers will be equal, sir.
just it is notation, and it's not equal. It's notation only.
Okay, sir.
So L equal to 2 means which orbital it will represent?
D, sir. D orbital.
D
So d
orbital.
orbital.
So that means what? In D there are 5 suborbitals are there, we can say 1, 2, 3, 4, 5. No. So generally, in now we are going to indicate this is if I'm taking p orbitals. No. Okay, if I'm taking this is p orbital. So as I'm taking there are 3 p orbitals, right? So 1 p, this is p, and in that p also we are having suborbitals, right? This I'm taking as px, this I'm taking py, and this I'm taking as pz. Okay. In this D also what we can say, there are having values. 0 indicates dz square orbital. Okay. And remaining indicates 2 indicates dxy, dyz, dzx, dx square minus y square. Understood what I'm trying to say?
Yes, sir.
Sir, for this, is there any formula? Just we write like that x, y, y, z, z
No,
square.
in d orbital there are 5 suborbitals are there, no? That 5 suborbitals names are dxy, dyz, dz square, dx square, dy square.
Sir, for this, is there any trick, sir? Like for
Nothing,
writing this
nothing,
one?
nothing, nothing. These are just IUPAC given only.
Okay. Sir.
Okay. Mm.
Sir,
Sir, is it
sir,
D
sir.
x square minus y square or x square dash y square, sir?
You can say any direction also, no issue.
Dx square minus y square, sir.
Yes, you can say dx square minus y square or dx square minus dz square also you can say, no issue.
So this dz square and dzx were given by IUPAC.
Yes, notation only given from there only. That means how the electrons in which direction they are orienting. Okay, from the shapes of that electrons only, orbitals only it was given. Okay.
Sir, wait, sir.
Sir,
Mm.
Sir, here also 0 is constant.
0 fixed, remaining you can interchange. Next one, Sinana. For example, if L equal to 0, which orbital it will indicates? S
Sir,
orbital, right?
it's
Yes,
orbital.
orbital.
S
Yes,
orbital,
orbital.
right? L equal to 0, how many ml values will be
So
there?
1, sir. So 0
One,
only.
sir. That is S only, sir.
There is only one value exist.
S.
S or 0? That value is 0, right?
Sir, you wrote value. You didn't.
Value is 0, okay na?
Sir, its name is only 0, sir.
0, 0 only.
Name, sir.
Right, that value na 0, that means what we can say, S orbital doesn't have any suborbitals, it means. Okay, S orbital doesn't have any suborbitals. Okay na? This is about the magnetic quantum number, Nana. And next one,
Spin quantum.
spin quantum number.
It's in plus 1 by 2 minus 1 by 2. Sir, why you wrote if L equals to 0 by S, sir?
L equal to 0 means it represents S orbital, I want to say.
Okay, sir.
Here also I have written L equal to 0, 1 means P orbital, L equal to 2 means D orbital.
So, sir, 0 is there in any value, right?
Hmm.
Sir, F orbital, you did not write.
F orbitals, there are total 7 will be there. That their orientation is not given, not there given, and not there in our syllabus also. Okay, but just you remember in F orbital we are having 7 suborbitals.
Okay, sir.
Sir, 7 means that is L value is 3, no, sir?
Yes. Spin quantum number proposed by and Goudsmith.
Spelling, sir.
UHLEN.
UHLE.
UHLEN. Uhlenbeck and Goudsmith. Okay. This gives information about the.
Sir, I didn't understand what are sub orbitals, sir. In orbit only they are there, sir.
Come again.
Where are suborbitals present, sir? In the orbits only. I didn't understand it, sir. What
Sir,
are suborbitals?
Ahlenbeck spelling is Uhlenbeck.
Yes. Okay. This gives information about orientation of electron. Okay. So in any orbital, the electron can orient in two directions. That is, either it can revolve in clockwise direction or anti-clockwise direction. If electron if I'm taking electron is there, it is the mean position, and if it is revolving in a clockwise direction, so it will have plus half. If the electron is revolving in anti-clockwise direction, then it will have minus half. Okay, these are the spin values we can say, right? And one more point, see, in what I am going to say is, this is the cell, right? For example, if I'm taking, okay, this is first shell. In first shell, what is the orbit? This is nucleus. In first shell, how many orbitals will be there? Only one s, right?
Yes, sir.
That I'm taking like this. And one s doesn't have any orbit, any subcells or not.
Yes, sir.
Whereas in second cell, what we are going to have? This is going to have 2s, and this is going to be 2p. Let me take like this. Okay. Or you can take like this also. That means 2s, 2p, and where it is there? In the same cell only. And in that 2p only, there are 3 subcells will be there like this. Okay. So these 3 cells. That
Sir,
means
those
what?
are 2px, 2py, 2pz.
Yes, that is indicated as 2px, 2py, and 2pz. That means what we can say is, so in 2p orbitals, the electron cloud will be in 3 possible directions. That is x direction, y direction, and z direction also. Okay. This is what we can say about the orbitals and in their points. And one more point, you please try to remember this. In an orbital, in an orbital, maximum 2 electrons can be placed. So in S, maximum accommodation of electrons in s orbital are out. How many it will be there, Anna?
2 electrons.
2, sir.
S orbital equal to 2. And in p orbital,
6, sir.
2.
Sir,
p
6.
we are having 3 orbitals, no? 3 suborbitals, right?
Yes.
P we having 3 suborbitals, right? And this is each orbital we can have 2 electrons.
Okay, sir.
And in 3p means total how many it will be there? 6 electrons. That is px2, py2, pz2. I say like that. In d orbital, how many electrons?
Sir, 10, sir.
10, sir.
10.
Sir, F
Whereas,
is 14.
in f,
14.
yes. E minus means electrons. Okay, na? This point also you need to remember. And one more point you need to remember.
Sir, in s orbital, 0 electrons, sir.
2 electrons. No, how it will be 0? I said no. In a one orbital we can have 2
Okay,
electrons.
sir. Sir, but in S, there are 0 suborbitals, no, sir.
Suborbitals are not there. It doesn't mean there is no orbital only.
Okay, sir.
Yes, we'll
Yes,
have
sir.
only one orbital. There is no suborbital. That is the question. No, I'm trying to say.
Yes, sir.
Sir,
I
can
didn't
you
say no.
Sir,
S is
once
not
could
having
you
an
move to the
orbital only.
previous slide?
One second. Let me write this point, and after that I'll go. Next point is the number of electrons in initial equal to, let me write in initial place in nth cell line, right? In nth cell 2n square. Okay, the number of electrons in nth cell equal to how many? 2n square. That means what we can say, in first cell how many electrons we can place? That is, in first cell how many electrons we can place, Nana? Wait, tell me here.
2,
Sir,
sir.
2, sir.
2. In second cell,
6,
Sir,
sir.
8, sir.
second cell that will
Sir,
be
8.
8 electrons. In third cell,
18 and 32.
number of electrons equal to how much?
18.
18. Okay, na?
Sir, I didn't understand, sir, how.
And just formula only, Nana. Just formula only I substituted, no? What did I say? Someone asked about the previous place, no? Please see
Yes,
that.
Yes. Sir, once could you explain the diagram again, sir?
No, it's not diagram. See, for example, say this is the mean position of electron, right?
Yes.
So with respect to the mean position, if electron, this is the indication of clockwise.
Okay, sir.
Okay, if it is revolving clockwise, it will have plus of. And this is indication of anti-clockwise, right?
Yeah.
For example, let me take, if a particular box or if any particular circle, there are two persons are there. How they can revolve? They can revolve in opposite direction only, no? Either they can revolve in same direction. If they are revolving in same direction, what will happen? There will be collisions can take place, no?
Yes.
In the same way, clockwise and anti-clockwise, if they are rotating, no, then there will be what we can say, there is no chance of collisions. So that means the stability of electrons will be more, because repulsions will obviously it will minimum, no? Because see, the electron will generally how electron will revolve, no? Simple, see how our earth revolves around the sun. First it will revolve around itself and it will revolve in its around the nucleus sun, no? That only we are saying, no? If earth revolves along its own position, then it will take 24 days. For complete one revolution around the sun, it will take 365 days, isn't it?
Yes.
In the same way, electron also it will revolve along its own axis as well as it will revolve around the spin. Sorry, spin nucleus.
Sir,
Understood?
how do we know that it is moving in clockwise or anti-clockwise direction?
That we can't know, Nana. Simply, it is prediction only.
Okay, sir.
We can't say, but only there are two possibilities. Out of two possibilities, if one electron is only there, so there are two electrons will be there, no, in the cell. Hello.
Yes, sir.
In
Yes,
a
sir.
orbital, there will be only two electrons, no, and you are saying that maximum two electrons. It can be one electron also. It can be placed, no. Yes or no?
Yes, sir.
And that electron will be. It can rotate. It can revolve along its own axis, or okay, or it can clockwise or anti-clockwise. It can take any direction. No, in that there is no point. Okay,
So can you stay in the previous slide for some time?
this one.
Yes, sir. No, sir. Next one. Next one, sir.
Sir, how many subshells are there? That many into two electrons they can fit, sir.
How many subcells?
Yes, sir. Three subshells are
Yes. Yes. N square, no subcells.
yes.
Number of orbitals are how many? You have written, no? Let me write. Oh, that also I will write. Number of
Sir, can you show the previous slide? I have a doubt.
I don't know what you are having doubt here. Ask me. Who is asking? Ranveer or Shashank?
Shashank, sir.
Tell me,
Shashank,
Shashank.
sir. not me,
Tell me,
sir.
Shashank.
Sir, I did not understand the 2n square formula, sir.
Actually, that is the formula given, Nana. Okay. For example, if I'm taking third cell, how many orbitals will be there? You tell me, Shashank.
3, sir.
Three. What are the orbitals?
Sir, they are 3s, 3p, 3d.
3s, 3p, 3d.
3d.
In 3p, how many subcells are there?
3, sir.
What are they?
3px, 3py, 3pz.
Very good. In D,
Sir, they are 3d, 3dxy, 3dyz,
total 5,
3d.
no? Total
Yes,
5,
sir.
right?
Yes, sir.
Total number of orbital, how many?
3.
1 plus 3, 4. 4 plus 5, how many? 9, no?
9, sir.
In each orbital, how many electrons we can fill maximum?
2, sir.
9 twos,
9 2s are 18.
that only I had written over there. Okay? Very simple I had given in terms of formula 2n
Sir, that
square.
means 6n square mean. Sir,
Hmm?
sir, in the place of n, what should we write, sir?
In which cell we are taking? First cell or second cell or third cell?
Okay, sir. 2 into 3 square, 18.
Yes. Okay?
Yes, sir. Thank you, sir. Understood.
Number of orbitals in a in in a shell or in a orbit. Let me write. In nth orbit. Orbit means, you know, na? Orbit is nothing but what? Shell, na? This is formula. Okay, number of orbitals in any shell will be
N square.
n square.
Sir, could
Okay.
you go to the previous slide?
Done?
Sir, how, sir? Number of orbitals in nth orbit is n square means third orbit 3 square, sir.
Yes.
6
Third cell means
orbitals.
3 square.
How 6 orbitals are there, sir?
3 square means 6. How it will be? 3 square is what? 9 or 6?
Sorry, sir. 9.
Just now I had given no 3s, 3px, 3py, 3pz, 3d. You only said no total 9 orbitals.
Suborbital. Okay, sir. Suborbital, sir.
Yes, all together orbitals we are calculating. Okay, na?
Okay, sir.
So this is about the quantum numbers, Nana.
Sir, 1 minute, sir.
You are getting notes, no?
Sorry, can more than accelerate, sir. Answer.
Next one, say. So after this quantum numbers, next topic is electronic configuration. What happened?
Shashank, sir.
Electronic configuration. So once after came to know how many atoms are there, etc., in that one. So what is the electronic configuration of the how to write electronic configuration of atoms? Okay. So while writing electronic configuration of any atom, while writing electronic configuration of while writing electronic configuration of any atom, okay, while writing any atom, okay, they we need to follow three rules. We need to follow three rules. That is, first one is Aufbau principle. Next, Hunt's rule. And third
Pauli's
is
principle. Exclusion principle.
Pauli's exclusion principle.
What is that, sir? Paulis?
Exclusion, EXCLUSION. EXCLUSION. Okay, na? Okay, na?
Yes.
Hmm. So first one, let me discuss Aufbau principle. Aufbau principle is, okay. So among various atomic orbitals we have no 1s, 2s, 2p, 3s, 3p, 3d, like that various atomic orbitals are there. No?
Yes, sir.
So among various atomic orbitals, okay.
So the electrons are filled in increasing order of energy level.
The electrons are filled in increasing order of
Energies.
okay, increasing order of energy values.
Sir, one clear set, sir. One sort of clear set, sir. One minute.
1 second, Nana. Done?
Yes, sir.
No, sir.
Yes,
Okay,
sir.
na? These are the energy values. So how we will calculate energy value? Okay, the energy value can be calculated n plus L values. Okay, so where n is principal quantum number, and
Other the
L
quantum
is
numbers.
okay. For example, if I'm taking 1s and 2s, what is n value for 1s? What is n value? 1s means what, Nana?
N is equals to
So
2,
two.
sir.
N equal to 1, no?
1s
1s
and
means
1.
what? 1
2
cell,
is
no?
2.
1. And L equal to?
0, sir.
And n plus L value is?
1.
1.
1, sir.
1, sir.
And for 2s, n equal to?
2.
2.
And L equal to?
0.
0.
And n plus L equal
2.
to? So in between 1s and 2s, first electron will enter into?
1s.
1s.
That is, electron enter into 1s orbital first.
Sir, in the second one, 2s, L is equals to 1, no, sir.
How L equal to 1?
N minus 1, no, sir.
Array, yaar, from where you are taking? What is L indicates, Nana? L indicates s orbital, no?
Yes,
L
sir.
indicates number of orbitals, no? Yes or no?
Yes, sir.
That one I did, no?
Sir, but L is equals to n minus 1, no, sir.
Array, yaar, Nana, L equal to n minus 1 means, okay, maximum value. From where it will start? Tell me. You people won't read completely, I think so. So for any n value, there will be n minus the total number of same values will exist. That is up to n minus 1, starting from 0, no? And we know clearly for s orbital, L value is 0, fix it is. And next, if I'm taking between 2p and 3p, in which orbital it will enter first? Tell me. What is n plus L value?
So, n plus L.
What is n value for 2p orbital?
Set 2.
L value?
0. No, no.
P orbital, no? P orbital, what is L value?
2, sir.
Array, yaar, you forgot or what? We have written clearly, no?
Yes,
L
sir.
equal to 0, L equal to 1 means p orbital, L equal to 2 means d orbital. That's what I'm asking.
1, sir.
1, sir.
That
So
is
3.
తీసుకెళ్ళి.
So 4.
Whereas for
So,
3p orbital,
sir, n plus L value is equal to 4, sir.
4, sir.
so n plus L value will be
4.
4. So electron will enter into first 2p.
2p cell, sir.
Next is next rule in that one only, next point. If any two orbitals having same n plus l value, then 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 electron enter into the orbital uh, which has least principal quantum number.
Sir,
Mm,
L means azimuthal quantum numbers, na sir?
mm.
Sir, before we wrote about magnetic quantum number, na sir?
You just please check your notes once. 2p and 3s, no? What is n plus l value for this? What is n value for
Sir,
2 or
2p and sir, 2.
Oh, sir.
l value will be 1. So n
Sir,
plus l equal
3.
to
3.
3. And where is coming into this?
Sir, 5.
3
N
plus
plus
0.
L1.
0, sir.
3.
Mm. So now both are having same n plus l value, right?
Yes, sir.
And in which is having least principal quantum number, 2p or 3s?
3, yes, sir.
By least
Sir, 2p.
2B, sir.
2p, no? That means what we can say between 2p and 2s. Okay.
Sir, it is 3 years, sir.
Sorry, between 2p and 3s, the electron enter into the which orbital?
2B, sir.
Enter into two p orbital. Okay.
Sir, can you go to the previous slide?
1 second, Anna. I will share whatever the backgrounds we are having right now. And from that one, we can write different for that one. To write the atomic orbitals in increasing order, we have one sequence. That is where you I'm going to give you that sequence. Please remember that. That is 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d,
5,
5f,
6,
6s,
6p,
6p,
60,
6d,
7s,
7s,
7p,
7p.
8s.
Sir, 8 this.
Okay. So we are taking like this.
What are the lines, sir?
Just I'm trying to write what is the sequence we are following. That's it.
1s, 2s, 2p, 3s, 3d, 4s, 3, 4s, 4s, 3d, 4p, 5s, 4d, 5p, 6s,
That means the order will be what we can say.
5d,
Order we can say is first
6p, 7s,
1s,
5,
2s,
60, 7,
2p,
8s,
3s, 3p, 4s, 3d,
3d,
4p,
4p, 5s, 60, 4p, 4d, 5p, 6s, 4f, 5d,
4d, 5p,
7s.
6s, 4f, 5d,
6p,
6p,
7s,
7s.
5f,
Okay, you need to remember this sequence, okay?
7p,
8s.
Okay, this is the order of filling of orbitals in various
minute.
atomic. Okay, na? Okay. Okay, students. Good night, all of you.
Thank you, sir. Good night, sir. Bye, sir. Advance Happy New Year, sir.
Bye, sir. Advance.
Happy New Year, sir.
bye sir,
Happy New Year,
advance.
sir. Good night, sir.
And all of you, Happy New Year. Take a good night.